What you see on your screen, ladies and gentlemen, is a multiple regression output. In that multiple regression, Q is the dependent variable. Q is the quantity demanded of gene betas. And quantity demanded of gene betas is the dependent or outcome variable. It is being influenced by the price of gene, by the complement price of gene, by the average income of the people, by the location of a shop that owns the bottles of gin. It is being influenced by the occupational type of the people, as well as the religion of the people. These are the things that affect or influence the quantity demanded of gene betas. This was estimated using ordinary least squares regression. The result of this regression have been generated here, and you have the estimate. I want you to please note that each estimate divided by each standard error will give you the t statistic. I want to repeat that. Please write everything I say down. It will be useful in both your assignment and in your exams. The exam is compulsory, so please, the compulsory is going to be on this, so please pay attention. Each estimate divided by each standard error will give you each t value. Once you go to the table, you go and read the t statistic, you will get the probability value, which is PR or P. Regression is the causal relationship between dependent variable and multiple independent variables. So we are going to now look at the first sort of question you might get in your own situation when a new preamble is given to you. Number one, okay, specify the entire regression model based on your regression result using the same labels as used by Python. Now, you guys are not using Python, you are using R. So as your R result tells you. So everything in your R result is what you're using to address the question. How do you specify the regression model? Who can tell us the difference between the specified regression model and the estimated regression equation? There are two differences there. Two main things. We've looked at it already. Who can tell me the first difference between the specified model and the estimated regression equation? Sawa. Okay, let me take it to Patience Body.
Prof, I remember the last time you said with the specified regression, it has an error 10 and I think a beta 10, if I'm correct. But with the estimated, you said it has no error 10.
And then?
But has a numeric coefficient, sorry.
Numerical coefficient, very good. That's exactly what I said.
Yeah.
Flashtrap, are you there?
Yes, please.
I want you to give 3 marks to Patience Body for me.
Thank you,
excellent answer. So that is a specified regression model. Okay. So in writing the specified regression model, take note of the fact that you have to have a beta parameter and an error term, no numbers. And you are supposed to use the information that you have in the regression here. The first thing to do is to write the dependent variable. What is the dependent variable here? What is the dependent variable here?
Q.
Is Q. The dependent variable is Q. Now, that means that on the left-hand side, you are going to write Q. Now, for most of the time, sometimes you'll bring subscript I to indicate that the Q is for each individual. So each individual will have that. Then you write equal to, and then you bring a certain beta. What will be the next thing you write after the equal to? What will be the next thing you write after the equal to? You write beta naught. Beta naught. And then you write plus, and then pick beta 1. You write beta 1. None of them is here, by the way. None of them is on your screen. But you got to have that from your mind. After you've written beta 1, you now pick the first independent variable. Okay. And that first independent variable is price. So you will attach the price to the beta 1. Then you write plus again. What would you write after the price?
Beta 2.
Beta 2.
C.
And you attach what?
B.
C.
B1.
What would you write again?
Plus beta
Beta
3.
And
M.
you attach what? M.
M.
Then what would you write again?
Beta 4.
Oh,
And then what?
location.
Location event. Location event.
No.
Log
Lock.
event.
Lock urban is a writing. If you don't write
Yes.
lock urban, but you rather write location urban or lock or urban, you'll be wrong.
Okay,
Everything
sir.
is 0. Please note that this specified regression model is 8 marks. If you make the slightest of mistake and go and write lock or urban, you will not get 6/8. You will not get 5/8. You get 0. Please take note. Giving you a marking scheme. So it's very important you follow the thing as it is. Then you write plus. What else would you write?
Beta 5 plus trading. Like teaching.
Okay, it's not plus, but it's beta 5 teaching.
Okay, sir.
And you write it exactly as it is in the result. Plus what again?
Beta 6 trading.
Trading.
So all of these things, you should know that. Okay, trading. You don't have to, please be writing what I'm writing. There's a reason why I'm writing. I could have shown you the result. I could easily have shown you the result, but I'm writing it for a reason. Then you do beta 7 what?
Beta 7 real Christian.
Well, Christians, the same way as you see it. Okay. Plus what?
Beta 8 real Muslims.
Real Muslims. Plus what?
Plus error 10.
Plus error 10. Now, there are 3 error terms you can write. You can write epsilon E, or you can write UI. Now, let's assume that you wrote everything, but you forgot the error term. How many marks do you think you get? You forgot this error term. And it is 8 marks. How many will you get?
0.
0. Thank you. So take note of all this. Okay, it's very important. Okay, so this is your result. Similar to this, that is what you will document. If you don't understand, this is the time to say it. The next one is another 8 marks, and it is this question. Question says that write the estimated regression equation, correct to 2 decimal places. How is this question different from the previous one? Who can tell us? How is this different from the previous one? Grace.
Doc, please, this time around, we are going to use the numerical coefficients, but then you said we should use it to 2 decimal places
Mhm.
from the model we generated.
Mhm.
Yes,
else?
please.
Then
And
what
With this one, you will not add
there's
the
no
FF.
error term.
There's no error term. That
Yes.
is excellent. So you go to your model. That is 3 marks for her. Class rep, take notes.
Yes, please.
What's the name of her? Did you notice the name, Araba?
Grace, yes.
Good.
Yes.
3 marks for her. See, some of you, the only way to pass or to get an A is these petty marks I'm giving you. You will see it. You will understand it later. All right. So you're going to write the estimated regression. What will be the first thing that should come? What will be the first thing you have to write?
Sir.
Bonnie, you don't like raising your hands.
Oh, okay, sir.
The day that you get a lot of people also doing what you are doing, your point will not be taken because they will overshadow you. So raise your hand, be used to it. Oh, you don't know where it is?
I'm still looking for it, sir.
Hey, you're in a modern 25th year. Bonnie, go ahead.
So this one, you write Q equals to -3. No. And Q equals to 280.27 plus 0.27.
Keep going.
Q equals to 280.27 minus 3.15 minus 0.11 minus 0.98 minus 8. Sorry, sir.
All right. So stop.
Sorry. So let me continue again.
No. The fact that you've gone all the way there means that another person will have to continue.
Oh, I wasn't adding the individual. Oh.
But you see, I didn't tell you.
Yeah, I've realized it. I've realized it.
So, guys, this is how the estimated regression should be like.
I wasn't adding the code.
If you are writing it, write it here. It will stick. Write it here. If you're taking notes, write it here. The estimated regression equation has numbers. And be careful, because some of the numbers are negative. If you don't take care, you think they're all negative. And then you will miss the one that is positive. If you miss the one that is positive, everything is 0. So it's important that you pay attention to details and you are writing the estimated regression equation. These two are 16 marks. Please know that the one you will have is more than what you are seeing here. In fact, you will notice that your assignment has more independent variables than you've ever seen in your life. So be used to formulating and writing the independent variables. Next question. So remember, we looked at 2 of the 13 questions so far. Question number 3. Which regression estimates are significant, justified? Which regression estimates are significant? What does the word estimate here mean? What is another word you can use for the estimate? You can tell us. What is another word you can use for the estimate? What is the other word? Coefficients. Coefficient. So which regression coefficients are significant? The word significant here means important. Okay. So it means that which regression coefficients are important. Now, how do you determine whether a particular estimate, so we are talking about these estimates. Okay. So when you take each one of these estimates here, one by one, Okay. Which one of them is significant or is important in influencing the dependent variable? Which one is important in influencing the dependent variable? To do this, you need to check the p-values of each independent variable. Please remember that you don't need the intercept. The intercept is not important when you are doing this. You check the p-value. The p-value is the last section for each independent variable. If the p-value is less than, write this down. If the p-value is less than 5%. So if the p-value is less than 5%, then that independent variable is significant. Another way of saying that the independent variable is significant is saying that it is statistically, above positive, or is it statistically positive or negative, depending on which one you're looking at. So is the independent variable significant or not? Let's start with price. Let's start with price. Is price, generally speaking, is price significant or is not significant? Who can tell us? Price. Tony.
Sir, it is significant
Why?
because 0.050 is less than, is equivalent to 0.05.
Sorry, say that again.
0.0, if 0.053, if you run it to 2 decimal places, you still get a 0.05000, which is equivalent to the 0 point.
Okay.
The p-value.
Right. Unfortunately, this person didn't ask you to round it.
Okay, sir.
So still go ahead and tell us what it will be. Unless you want someone to take over.
Sir, I didn't get a question, well, sir.
Okay. So ponder over the question whilst you're listening to others. Jonathan.
Yeah, sir, it's not because it is more than 5%.
What is not?
The 0.03, 0.053.
What is not? You said it is not. What is that it?
No, you're asking if the 0.053 is significant, and I'm saying it is not
I
because
didn't ask if 0.053 is significant. That's not what I asked.
oh, okay.
There was something that I specifically asked whether it is significant or not. So let's Araba explain it to you. Araba Pratt.
Yes, please. Thank you, Prof. So the regression coefficient of price is not significant because its p-value is more than 0.05.
What is it?
It's 0.053106.
Which is more than 0.05.
Yes, please.
And that is why.
More than 0.05.
And that is why what?
Satan and his works, they turn around and attack
and that
me.
Is why what?
And then they began to report
Okay. Let somebody take over. That is why what? Emma. That is why what? Sewa.
And please, that is why P is significant.
That is why P is significant. Okay.
The estimate of P is significant.
Now you're talking properly, which is much better. So that is why the coefficient of P is said to be significant. Okay, now is the coefficient of complement price significant or is not significant? Complement price, you can tell us. Is it significant or insignificant? Funny.
So it's significant because it's less than
What is less than?
The coefficient of C. The p-value is 0.008860, which is less than 0.05.
Good, excellent. I'm giving 3 marks to Pony.
Thank you, sir.
Do you know why I'm giving it a 3 marks? It's not because of the answer he just gave. But it's because of what? Oh, you don't even know why I gave it.
His contribution.
Contribution to the body of knowledge. It's because of his participation. Okay. All right.
Thank you,
So
sir.
who can tell us whether the average income of the people, the M, is it significant or insignificant? C, is it significant or insignificant? Amma?
Please, are you saying C or M? Because we've dealt with
Sorry,
C.
M. Sorry, M.
Okay, so please, M, when it comes to M, the P, which is 0.203, it is greater. So P, if it's less than 0.05, that is when the independent variable is significant, but 0.2030 is greater than 0.05. Therefore, M is insignificant, the estimate.
Perfect, excellent. Let's go to Loch Urban. You can tell us about Loch Urban. Loch Urban. Is it significant or insignificant? Grace.
So please, when it comes to log urban also, the p-value, which is 0.18, it's greater than 0.005.
Since you
Therefore,
said it's 0.18, you have to be specific. Since you stopped at 8, you have to be clear whether you've taken into consideration the decimal places.
okay, so please let me mention also, since log urban, the p-value, which is 0.186823, is greater than 0.05. Therefore, it is insignificant, the estimates.
Correct. Occupation teaching, teaching. Is it significant or insignificant? Mary.
It's significant.
So since occupation and teaching, the p-value as 0.0000423 is less than 5%. So it means that occupation teaching estimate is significant.
Correct. Occupation trading. Is it significant or insignificant? Occupation trading. Barbara.
Hello, sir.
I'll raise my hand.
It's
John Boama.
insignificant because the p-value of occupation trading, which is 1.08 times 10 to the exponent -9, is less than 5%. So it means that the estimate of occupation trading is significant.
Barbara, what does that value you mentioned, what does it actually mean?
It means the decimal point will go back 9 times.
So what does it actually imply?
So it implies that it will be 0.00000 something.
Therefore,
Like coming.
what does it approximately imply?
It implies that the p-value is less than 5%.
So what does the p-value there mean? What does it mean? In short, the p-value is what?
So it's significant. The estimates
I
of the
know that
occupation
one. I
trading
know
is
that one.
significant.
What is the actual value of the
Uh-huh.
p-value?
It's 1.
It's not 1.
It's 0.
It's not.
So it's 0.
Zero,
It's
zero.
It's
It's
0.
0.
Hey,
Yeah.
yeah. And somebody whom I have not called just shouted the wrong answer too. The person has not even been called and said it's 1. So check carefully. At least raise your hand. That will help you. Okay. All right.
No, I've searched
All of,
for it. I couldn't find it.
all of these imply that you need to be able to interpret your results. Okay. This is 5 marks, so it's very important that you learn how to do it. Now, let me give you a clue. There is a star for each of these variables. The stars should guide you to know the level of significance. Now, this is very important because this is part of your question. Anytime you have a star, that is 3 star. 3 star is equal to 0.1%. Take note. 2 star is equal to 1%. 1 star is equal to 5%. And a dot is equal to 10%. So even though price is not significant at 5%, it is significant at 10%. Note that down. This is important. Even though, yes, Araba, why is your hand up?
Yes, please. I want to ask a question, Prof. So I want to ask, in answering this question, could we have said that like a short form, because of the number of stars attached to maybe price is a dot, so it means it is not significant because it's and then we will say that the
Well, the point is that under exam condition, I will not give you the stars.
Okay. Thank you.
In the assignment, you will use the stars to make in your thesis, in your write-up, in using this practically, in your practice, in your dissertation, in your long essays, in your thesis, you will need the stars. But then I wouldn't give you the stars. But you should be able to know the stars. Now that I've given you the rules of the stars, you should be able to know that the stars can easily be deduced. Just using the p-value, you will know how many stars it is. For example, look at price. Price is actually 0.053. So it means that the percentage is actually 5.3%. Just look at that. So 5.3% is above 5%, but it's below 10%. Therefore, it's significant at 10%. Look at the C, the complement price. The complement price is actually 0.008. So if you are to round it, it's going to be 0.01, which means that it's actually 1%. Okay, 1%, what does that mean? Or no, not even 1%. But if you have to just take it, well, 1%. 1% is 2 stars. So just the fact that it's 1% should tell you that it's significant at 1%. So you can just use the p-value to calculate easily how many stars it has. For example, look at Loch Urban. Loch Urban is 0.1868. So that is 18.68%. 18.68% is way above 5%, way above 10%. Therefore, it is insignificant. It is not just like it's significant at 10% or significant at 5% or significant at 1% or significant at 0.1%. No, it is insignificant simply because that 18% is way more than 5%. But if you look at occupation teaching, when you check the value, the p-value alone tells you that it's purely 0. is purely 0. So that should tell you that, oh, if it is purely 0, then the stars must be 3 stars. If it is purely 0, that's the highest, the lowest point one can go, then it is significant at 0.1%. So you can use the p-value alone to determine even how many stars there are at each point. This is important. Now let's go to the next question. So all of these are called partial significance. Everything we looked at. We are looking at individual variables. Now, you could have also done a statistical test using the t-test. The t-test is what you see here. Okay? The t-test is basically the difference between the estimated beta and the true beta divided by the standard deviation. The standard deviation is the square root of this variance. And you can use this one to also calculate the confidence interval. But that's for another day. Okay. Now, the question was, which independent variables are significant, or which independent variables are statistically different from 0? It's the same question. Now, that's the question. We just looked at it some few minutes ago. Okay. So those are actually 4 questions we've looked at so far out of the 13. Let's go to the next one. The next one is interpretation. You would interpret a coefficient of a numerical variable, and you will also interpret the coefficient of a categorical variable. You see, the coefficient of a numerical variable is dynamic. A numerical variable is a variable that is dynamic. That's why they are numerical. It means that variable can rise and fall. But then a categorical variable, also called the dummy, okay, that categorical variable is not dynamic, it is static. In other words, at least within a year, it doesn't change haphazardly. So most dummy variables like gender, they don't change haphazardly. Yeah, in some countries, maybe they might call themselves transgender and other things. However, that does not even change every year. We use once a year to. So people don't go to change their religion every year. Think about it. So it's static. It's not dynamic. But the prices of goods are what? Are changing. Prices of goods are dynamic. The weather is dynamic. The weather is dynamic. The price of gold is dynamic. The price of t-shirt is dynamic. Okay? But the occupation of a person, occupational type of a person is static, generally speaking. So how you interpret the coefficient of any variable matters whether the variable is dynamic or is static. So first of all, let's look at the coefficient. One of the coefficients is price. The coefficient of price is actually negative 3.15, corrected to decimal place. You got to learn how to interpret this. Remember, first of all, price is numeric and therefore is dynamic. How do you interpret this? You always start with the word on average, because this is a regression. It's a causality. It's based on the mean. And then you hold the other factors constant. Now, sometimes some of the literature will say, holding all other factors constant, holding all other factors constant, holding all other factors constant. I want you to learn how to write these other factors. Just mention those other factors that are given, that are held constant. Don't say that holding all other factors constant. Just mention the factor, because there's a technique to that. So watch something. I'm going to interpret the coefficient of price. Learn from that to do the interpretation of the other. So you start by saying that on average, given, and then you don't mention the price, but you mention all the others. Okay. Since you are talking about price, since you are interpreting the coefficient of price, you don't talk about price, but you talk about the others. Because at that stage, you are talking about price, so you are not holding it constant. You are not holding it as given. No. So you start by saying that on average, given the complement price of gin, the average income of the people around the shop, the location of the shop, the occupation of the people, and the religion of the people. A 1 unit increase in the price of gin, a 1 unit increase in the price of gin reduces the quantity demanded of gin by 3.15 units. A 1 unit increase in the price of gin cuts down the quantity demanded of gin bitters by 3.15 units. Now you realize that I held everything constant except the one I was interpreting. This is the right way. Also, I did say that a 1 unit increase in the independent factor, the independent variable you are talking about, it is that one you are increasing its price by 1 unit. I mean, its value by 1 unit. So I said that a 1 unit increase in the price of gin reduces the quantity demanded. Why did I use reduces? Why reduces? Grace.
Because it's negative.
Negative.
Is that Grace who spoke or someone else talking without me calling the person?
Oh, Doc, they didn't let me talk. Oh.
Sorry?
They didn't let me talk, so it's fine.
Yeah, I want to know the one who didn't let you talk.
I'm sorry, it's Jerry.
Jerry, yeah, please help us to make everybody happy. But I'm still going to give Grace your 3 months because she said it whilst he was saying it. And I'm sure you know why I'm giving you the 3 months, because of the exact answer you gave. Grace, are you there?
Yes, Doc, I'm here. Thank you very much.
Is that your first 3 months?
Please, no, this is my second.
Yeah, you're doing well.
Thank you, Doc.
It's because your name is stuck in my cerebral cortex. All right. So that is because the 3 is negative. That's why we say reduces. So when you increase the price of gin, quantity demanded will fall by 3.15 units. Remember that I used the word units. Units. I didn't say quantity demanded will fall by 70% or dollar or CD. No, I use unit. So all the time, keep it a unit so that you don't change the unit of measurement. After you said all this, then you add a full stop. Then you continue by saying that even though this is not significant at the default 5%, and it's true, it's not significant at default 5%, it is still significant at 10%. So always mention whether or not it's significant at what percentage point. Always mention. This is how you interpret the coefficient of price. Now let's go to the interpretation of the coefficient of another thing that is not price. You see, the other thing that is not price is so many other things. But I'm just going to pick on Muslims, religion Muslims. Religion Muslims is one of the coefficients. Is it a dummy variable or is a numeric variable? Who can tell us? Religion Muslims. Is it dummy or numeric? Bridget.
Please, is a dummy variable.
It is a dummy variable. Now, because it's a dummy variable, you got to interpret it as a static variable. In other words, it's not moving. It's not rising or falling. So the way you interpret a dummy is different from the way you interpret a numeric variable. Let's look at the coefficient first of all. The coefficient of the price of religion Muslim, or the coefficient of religion Muslim is negative 23.01. Correct to 2 decimal place. Negative 23.01. How do you interpret this? You still will start with an average. But before you do that interpretation, you got to know the reference category. You see, religion Muslim is one of the religions in this very preamble. There were 3 religions. 2 of them have been provided here, which is the one that was not provided. Who can remind us? Before you start any interpretation, remember everything about your story. Before you start. Samuel.
Buddhist.
Exactly, it's Buddhist. Buddhists are the ones who are not here, and therefore it becomes a reference category. See, the reference category means that it is the one you compare every other thing with. So if you look at religion, anytime I talk about Christian, I'm talking about Christian relative to Buddhist. Every time I talk about Muslim, I'm talking about Muslims relative to Buddhist. Every time I talk about location, urban, I'm talking about location, urban in relation to what? Christabel.
Several.
And anytime I talk about occupation teaching, is in relation to what? Christabel. Bridget.
The occupation fishing.
Occupation fishing. So it's related to fishing. That's what I'm actually talking about. So you must have that at the back of your mind. So on the basis of that, we can interpret the religion Muslim. On average, given the price and complement price of gin. You see, this time I'm mentioning price. On average, given the price and complement price of gin, average income of the people, location of the shop, occupation of the people. I don't talk about religion because that's what I'm talking about. So I don't hold that constant. So on average, given the price and complement price of gin, average income of the people, location of the shop, and occupation of the people, quantity demanded is predicted to be 23.01 units less if the people are Muslims than Buddhists. Quantity demanded is predicted to be 23.01 units less if the people are Muslims than Buddhists. It's beautiful. And then you conclude that, and this is significant at what percent? You can tell us. This quantity demanded is significant at what percent? This statement is significant at what percent? Grace.
The 0.05.
Okay, that is not correct. It's not significant at 0.05. It's significant at what percent? Aima?
0%.
0% is wrong. Significant at what percent? I don't want anybody to shout the answer. Bridget.
So 0.001.
So what percent? The significant at what percent? Anita Koko.
0.1%.
That's it. 0.1%. Guys, you got to know how to convert decimals to percentage so that you don't always get lost. Other than that, you're always going to be fumbling. You are learning something unique. That is how you interpret a coefficient of religion. This is it. It's on the screen. Next one. So interpretation is very important. Interpretation alone is 7 marks. Okay, for each. You've got to learn how to do the interpretation very well. You will always have one interpretation based on a numeric variable, another interpretation based on a categorical variable. Master them. Master them. Next question. So far we looked at 7 questions now. Is a regression model well fitted? Another way of asking that question is a regression model dependable, reliable? And interpret your question. Interpret your answer. The entire regression is establishing a causal relationship between a dependent variable and multiple independent variables. That's the whole regression. You want to look at factors that are claiming to influence quantity demanded. You want to look at factors that are claiming to influence consumption. You want to look at factors that are claiming to affect corruption. You want to look at factors that affect GDP. You want to look at factors that determine blood pressure. You want to look at factors that affect salary. Regression looks at determinants of something. Determinants of something. You will use this in multiple work. Multiple work. Most of you will use this in your thesis, your dissertation. Now, if you want to know whether the regression you have done is reliable, you got to check something. And that something is known as the R square. Now, there is a formula for the R square. The R square is a residual sum of squares, also known as the error sum of squares, divided by the regression sum of squares, also known as the RSS. Now, the R square is also called a coefficient of determination. It tells you the total percentage variation within the dependent variable as it has been explained by all the independent variables combined. That's what it's doing. It is telling you that if you look at this dependent variable, if you look at this quantity demanded, how many percentage variability has been explained by those guys that claim to be independent and therefore influencers, and therefore they are predictors to predict that dependent factor. How much is a percentage variability? So the regression model will tell you how good or how bad a model is. The bigger the value, the better. If the R square, which is in percentage, if it is closer to 100, is great. If it is closer to 0, is bad. I always say, this is my rule, based on Hare et al. 2005 book, that when the regression R square is bigger than 5%, then the model is bigger than 50%. Then the regression model is well fitted. Sure. If it is bigger than 50% is well fitted. Let's go to our model and look at the R square. You will always find the R square at the bottom of your results. There is also another one called adjusted R square, but then it's not actually called fully R square. The actual name is multiple R squared. Correct to 2 decimal place, what is the value of the R square? Who can tell us? Tony.
$99, 0.99. So it's 99%, sir.
99%, very good. So that is the value of the R square. Now, using this R square, would you say that the regression model is reliable? And why?
It's reliable because it's...
I wasn't actually calling you.
Okay, okay.
Jerry. Jerry. Ayima.
Sir, please.
Jerry, you are not focusing. You are not paying attention.
More than 50%.
Sorry?
I said it's reliable because it's more than 50%.
Why did it take you that long to reply?
At my mic, I think I was trying to put on my mic.
Pay attention, guys. When you raise your hand, it means you are ready. That is what it means. Okay. So when you raise your hand, be ready. So it means that a regression model is reliable because the value of 99% is bigger than 50%. Now, my question to you all is, how do you interpret this score of 99%? What does that mean? Based on the definition I gave you earlier, what does that 99% actually mean? Who can give us the answer to that? What is the meaning of that 99% R square value as it relates to this particular, to shop thing we are talking about? What is the real meaning? What is a mean? Simple language. Don't complicate things. Based on your understanding, not based on your reading. Yes, Bridget.
Yes, sir. Sir, it means that this regression model is reliable.
No. That one is when I ask you whether it's reliable. But I'm saying, what does a 99% mean itself? When the 99% is greater than 50%, that is when we say it's reliable. We've already answered that. But what is the real meaning of that 99%? What is the interpretation of that 99%? Marvin.
It means that the independent variables explain 99% of the dependence variable.
You were close, very close, but you missed some keyword. Who can raise a hand and polish it? What he said, he missed an important keyword. Barbara.
Yeah, please, it means that the influence of the independent variable on the dependent variable is 99%.
Be specific, because at this stage, you don't use the word independent and dependent alone. You got to be specific because we know exactly which one is what. Use the real names in this particular context. Contextualize your answer. Contextualize the answer. Grace.
Okay, so please, based on what my colleagues are saying, I think they are trying to say that the dependence variable, which is the quantity demanded QD of the gene, and then the independence variables, which are price.
Okay, so at this stage, you can now omit those ones. At least you mentioned the dependent.
Okay. It's influenced by 99%.
So what is being influenced by 99%? Let's get that clear.
The dependence variable, which is QD, the quantity demanded.
The entire model.
There's something I'm looking for.
The consumption of brukutu.
Masa, Jairov. We are not drunk. Yes, yeah. So what this means is that we are looking at, so what is being influenced is not just the quantity demanded of brukutu gene bitters, but rather the variability. The variability. Anytime there is a change within the quantity demanded, okay, that change within the quantity demanded has been fully explained by all the independent factors. 99% of those variability or variation have been explained. 99% of the variation within the quantity demanded of brukutu gene bitters has been fully explained by these independent factors, by these predictors. And that is why we believe that this is reliable. Because to explain 99% of whatever you are doing. So anytime quantity demanded of gene bitters increases or falls, this increase of fall is being influenced. 99% of it is being influenced by these factors. Now, it means that there are other factors, all right, but those factors are just influencing 1%. Understand the context. It's very important. This was question number 8. And question number 9. It's very important you understand it too. Okay, let's go to the next one. The next question, and in fact, this is not a question, I'm just digressing to tell you something. There is also something called adjusted R square in the result. What is the difference between the adjusted R square and the R square? Who can tell me this? I've not taught you anyway, but I want to see whether anybody can tell us. If you can, if you know already. But if you don't know and you're Googling, you'll be caught. You asked a series of questions. All right. So the adjusted R square penalizes the inclusion of irrelevant variables in the regression. The R square is good, but the R square doesn't punish you if you include irrelevant variables. The adjusted R square penalizes you. And I'll give you an example. Let's say that we are looking at the factors that affect blood pressure. The last time we were looking at it, I said nobody should mention heart attack, broken heart. Suppose you believe so strongly that broken heart should lead to high blood pressure, but this is on some, very, very special occasion. It doesn't really happen. But so many people have had broken heart and they never had high blood pressure. But you are so strong in your belief that this will cause heart attack or high blood pressure. And so you included broken heart in the data set. And when you did that, the R square, which was potentially 99%, came down to 96%. Which means that that irrelevant variable you included has been punished, but the R square will never come down. You see, I said the R square has come down to 96%, but the R square will never come down. It will still stay at 99%, even though you have included an unnecessary, irrelevant variable. So what the R square does is that it penalizes such an inclusion. So whenever there is that kind of irrelevant inclusion, the adjusted R square comes down, and that's it. Now, the R square, when it is equal to the adjusted R square, what does that mean? When the R square is equal to the adjusted, by the way, I'm talking about both of them here. When the R square is equal to the adjusted, what does that therefore mean, Marvin?
All the independent factors were relevant.
Perfect. 3 marks for that. Okay, that's your take note of that. It means that all the independent variables are relevant. What is the lowest value the R square can go to? You gotta be smart to answer this. What is the lowest value the R square can go to? Oh, sorry, hold on. Let me put it this way. What is the lowest value the R square? Yeah, that's the question. What is the lowest value the R square can go to in terms of relevance? I think this is a tough question. And I know probably somebody can crack it. Who can crack it? What is the lowest value the R square can go to? Lawrence.
0.49999.
No. What is the lowest value the R square can go to? Emma.
0.1. 0.
I said Emma. Emma.
Yes, Prof. Please, 0.
0. That's wrong. What is the lowest value the R square can go to? Grace.
Please, is it 0.1?
No. You see, for me to ask you that question, and since that they are percentages, obviously, if it was 0, I wouldn't have asked you. It can go to Eunice. Your hand is still up. I know.
So also going 0.1.
Okay, don't worry. So the lowest value the R square can go to is the value of the adjusted R square. Think about it before you see it somewhere. That's the lowest value it can go to. Okay, because that is when there's no irrelevance. All right, let's go to the next set of questions. All of this. The adjusted and the R square have all been given here. So try and get some of the formula. Okay. Now, apart from the R square, there are other factors you can use to determine whether the model is good or not. One of them is the log likelihood ratio. It's just here to help you. It's not something you should learn it. It's the log likelihood ratio, the L. Another is the Bayesian information criterion. That is also here. And the final one is the Akaike information. criteria, Akaike information criteria. These are other things like the R square. That also tells you the fitness, the reliability, the dependability of any regression model. Very good. Now look at the results again. Fill the rhythm. Fill the rhythm. Araba.
Sorry, please. I wanted to find out with the other models that could be used. Are we to know them offhand?
No.
Okay.
You have to know them when you are rather doing your dissertation, but not for this course per se.
Okay, thank you.
The next question is, determine the joint significance of the regression estimate and explain it. Determine the joint significance. Now, the previous one we just looked at was the partial significance. Partial significance is when you are checking how each variable is significant, how each variable is significant, how each variable is significant. That's it, one by one, partial significance. Partial significance, that is individual significance, individual significance. But this one is together significant, joint, together significant, joint. Have you heard of the statement that says that if you take a broomstick, you can break it, but if you take the entire broom, you cannot break it? What does that mean? 3 words. What does that mean? Emma.
It means unity is strong.
That's a unity is strength. Unity is strength. So the first series of questions on significance we looked at was individual. Some of them can be insignificant. For example, you remember that C was insignificant, M was insignificant. Oh, sorry. C was significant, but M was insignificant, and location urban was also insignificant. The question now we are trying to look at is, what if you put all of them together? How do you determine the joint significance? All of them put together. You need something to help you to do that, and that is the F statistic. It is at the very bottom. The F statistic will tell you the joint significance. You can use the statistic and compare it with a critical value, like we did in ANOVA, or you can just use the p-value and compare the p-value with alpha. And alpha is always defaulted to 5%. So all you got to do is to check the p-value, and if the p-value is less than 5%, then you can conclude that all the independent variables combined together are jointly have been tautological, just for emphasis. All the independent variables are jointly significant in influencing the dependent variable. In this case, all the independent factors, all the regressors together importantly or significantly affect the quantity demanded of Brukutu gene betas. So the question now is that the case? Are the independent variables jointly significant or they are not jointly significant? Who can tell me? And give me a reason. Looking at your table, are they jointly significant or they are not jointly significant? Anna.
So please, from the statements you just made about p-value being less than 0.05 to make the independence variables jointly significant, looking at our p-value here, which is a lot of zeros, about 16 zeros before the 2. So 0.0002. And it means that is less than 0.05. So they are jointly significant, the independent variables.
Excellent. That's 2 marks. It means that the independent variables are truly jointly significant. With a good explanation you've just vomited here, I mean, what kind of blood do you have? This girl is just Fanta Bruta. You are Fanta, not Coca-Cola. That's really excellent answer. You have immersed yourself in the sea of good research, econometrics. That's really good. These are the people you should befriend, guys. Not the one you are befriending. These are the people you should get to know. Find out their names. Give them gifts.
Yes, sir.
Pamper them. Pamper them.
Are the
Because
boyfriend, sir?
that person who is your friend has not been helpful. At least for the nature of this course has not been helpful. So when it comes to this course, tell the person, stay in your corner zone. After the course may be fine. Okay. But during such kind of intellectual, sponging, these are the people you should get to know, befriend them, because they will baptize you in the sea of good research methods. All right. So everything she said is right here. But she interpreted it from her heart, but I've given you the write-up here so you can check it. Joint significance. It's a very, very important question, and you should take note of that. Take note of that. That joint significance can be statistically estimated like a hypothesis test, just as we used to do in ANOVA. Okay, and the hypothesis test is all being provided here with all the nitty-gritties. I'll get to know it, but I'm not going to bore you with a lot of questions on that in the exam, but I just want you to know it, because at your level, you can't say that you don't know how to hypothesize the joint significance of all the coefficients. This is it. Okay. Now, that is question number 11. That was question number 11. Now, question number 12 is about prediction. Pay attention here, ladies and gentlemen. Pay attention. Pay attention. Pay attention, please. The biggest question you can ever have is prediction. 30 marks. That's question you see, and you appreciate this. It's a very deep one. There are two reasons why we undertake regression as a technique. You see, regression is like ANOVA. Regression is a technique, just like ANOVA is a technique. Regression is a technique, just like ANOVA is a technique. Now, I want you to take something like you're doing a research. You'll be surprised that in the research you're doing, the major technique you'll be using to address all your research questions is regression. But before you undertake a regression in your thesis, in your dissertation, there are about 5 things you will do before you do the regression. One of them is contingency table, if they are groups. We've looked at that before. We've used the book to data set to look at contingency table. I hope you remember. And it's also in your slides. Please, if you haven't, look at it. Number 2, descriptive statistics, where you look at the mean, the median, the mode, the kurtosis, the variance, the range, the skewness, all of those things. It's just to give you a descriptive nature of your data set. The third one is correlation. You remember we generated a correlation matrix last time, and based on the correlation, I've given you the videos to watch on that. In fact, I have 7 different videos on correlation matrix in the channel. Watch them. And then after that, and I'm telling you, this is it. This is a whole researcher. This is it. That if you are doing your actual research, this is it. Of course, if it is a quantitative research. Sometimes even the qualitative research will come and use some of these. Then you got to do something else, which is known as visualization. So you bring a couple of graphs to hone the point. Visualizations. And then the 5th one, the key one, is regression. But what is the essence of regression? The essence of regression is to do 2 things. Number 1 is to establish relationship. Write it down. Number 2 is to predict. Once the model is built and validated, you have to use it sometimes to predict. In this case, to predict the quantity demanded of gene betas. Sometimes you even have to hold a data set somewhere, especially in machine learning or artificial intelligence. You hold a data set somewhere, and then you come and use use the estimating procedure you did in the training data set to validate it on the test data set. Now, these things, I'm not going to ask you questions on them, but I just want you to know practically what you'll be doing in your normal research. Sometimes the dependent variable, you have to take the logarithm, natural log of it. For example, our dependent variable is quantity demanded. So sometimes you want to take the natural log of it. You can do that in Stata. You can do that in R. You can do that in Excel. So when you go to Excel, you say, I want you to take the natural log of this column, and it will take the natural log of all of that column, put it in another column for you. Why do you do that? Why do you take the log? Because sometimes the variable is in nominal and you want it in real. For example, take inflation. Inflation is a nominal thing, but the real inflation is important than the nominal inflation because the real inflation will determine the purchasing power. Sometimes look at your salary. Your salary might be 10,000, but it doesn't buy anything much because your salary is nominal. So somebody is actually earning 1,000. The person's salary has gone up to 1,002. The person is jumping. Meanwhile, prices of goods have gone up in tandem with your increase. Prices of goods have gone up. Why are you so happy? Why are you so happy? Why are you so happy? Because the situation is still leveled. Your salary has gone up in nominal terms, but the purchasing power has not gone up because things have still also gone up. So you are still losing. So that's why sometimes we say that when you put your money in the bank and there's an inflation, you are in trouble. A lot of people put their money in the bank. What happened? The cedi appreciated against the dollar. So if your money was dollar, you are suffering. You are not doing well. That is why it is sometimes important to take the log. We need to transform this value from log scale back to its original form. Okay, and sometimes you have to do something we call log transformation, and you have to take the exponentiation. Somebody mentioned that some minutes ago. Don't worry, but these are some of the things you have to take note when you are doing practical work. Now, so we're going to do prediction using what we have here. The same thing, nothing has changed. How do you do it? Here's a quick question on prediction. How much higher is the quantity demanded predicted to be? Suppose price should increase by 8 cedis. Now look at it. If price should increase by 8 cedis, what should happen to quantity demanded? Assuming that everything else is constant, nothing has changed. This is what happened. If we want the value of quantity demanded, we want to predict the value. But we know the equation. Just using the price, the equation is going to be 280, which is the constant, the intercept. Write it down. A 280.27. Then minus 3.15, that is a coefficient of price. Okay, so 3.15. Then you attach the word price to it. So now the question is, we have increased price by 8 cedis. What do you do? Once you increase the price by 8 cedis, just substitute whatever you see price or P with that 8 cedis. So whatever you see P here, you put 8 cedis there. So the predicted quantity demanded will now be 280.27 minus 3.15 multiplied by 8. You take your calculator and you do the calculation. Who is the fastest person who can give me the answer? Terence.
255.07.
Very good. That becomes the predicted quantity demanded of gem bitters if price should go up. So you see, it has brought the quantity demanded down when price went up. which shows the negative relationship between the price and quantity demand. So you can always do a prediction, provided the independent variable should change. You see that the dependent variable, which in this case is quantity demanded, will also change. Now, what you gave us was the actual quantity, but the change is going to be the 8 times the 3.15. Here, I think I did 3.16, but it's similar to that. The actual change, the actual increase is, but then the original value will be different from the actual value. Okay. And the reason is because of the intercept. Please go back to the intercept. The intercept, I told you, that is useful, is not even economically meaningful except during prediction. And that is what was shown here. The intercept brought to the prediction. Let's take a real life situation for this one. A real life. And you're going to do it together. Everybody is going to do it together. I will encourage you to do some, because this is 13 marks. If you get it, you are flying. Okay. So here's the thing. We are going to compare two things. One, you're going to compare the quantity demanded of gin bitters from two sources. One, by some Muslim traders in an urban area. That's the first one. Muslim traders in an urban area. Compare that quantity demanded with that of the quantity demanded made by some Buddhist fishers in a rural area. The second one. But in both cases, given that both cases, okay, the gin bitter cost 5 or 15 cedis. So whether it is by the Muslims or the Buddhists, the price of the gin bitter or the gin bitter cost 15. Okay. In both cases, they have a complement price, which is 15. And also the income is 20. Which factor or which factors appears to be causing the difference, in case there's difference? How will you handle this? The first thing you need to do is to write your equation down. Write your regression equation down. Ladies and gentlemen, who can tell us the regression equation? Because I told you all to write the regression equation when I was giving you. Who can tell us or write the regression equation verbatim for us? The regression equation, verbatim. Mm-hmm. Who can tell us the regression equation? We gave it out. This is a regression equation. Write it down. Right, all of you should write it down. And even though I'm saying all of you should write it down, some will still not do it. Write it down, please. Write it down, please. Write it down, please. Write it down, please. Write it down with your pen. Write it down with your pen. Okay, so now we go to the storyline. We are told that the quantity demanded is between Muslim traders with in an urban area and that of the Buddhist fishers in a rural area. In all cases, we have 15, 15, 20 for the price, for the complement price, and for the income. So let's take the first scenario, Muslim traders in an urban area. we come down here, we have to fill in the letters. Okay, the letters now. What will be the value of P? What will be the value of P?
15.
Very good. What will be the value of C?
16.
What will be the value of M?
20.
What will be the value of log urban?
1.
I love that. Remember the story. For those of you who don't know, we are talking about Muslim traders in an urban area. I just hope that you, the one talking, you are saying it from your head. Are you saying it from your head?
Yes, sir. Yes, sir. Yes, sir.
Can you tell us why it is 1?
I'm putting things together, sir.
Okay. You are watching. Tell us why it is 1.
Because the person is in the urban area.
Exactly. Based on the question, isn't it? So based on the question, we were told that this very or these people are in the urban area. So if they are in the urban area, then if it is urban, if location is urban, then it should be given a value of 1. But if we were told that they were in a rural area, then this location urban would have been 0 because it will not match with the rural. That's how you analyze the dummies. The dummies are analyzed 0 or 1. Okay. What will be OC teaching? Remember the story here, Muslim traders in an urban area. What will be OC teaching? What will be the value of occupation teaching? Grace.
So please, based on the story, we coded it with 1.
That is wrong. We are told that these are Muslim traders in an urban area. So occupation teaching will be what? Aima?
Sorry, it will be 0.
Why?
Because we are talking about traders.
And?
Traders will be 1.
I said we are talking about traders and?
Let me say the question again.
You have to complete the sentence. We're talking about traders, and this question, this part here was about occupation teaching. The people are traders, and yet you are telling me about
and fishers.
Okay. Stop. So you're confusing yourself. You're confusing yourself. You are trying for things to work. Pay attention. There's a need for understanding than trying, and then when the thing falls apart. You are told that we are talking about scenario 1. In scenario 1, the people are Muslims, they are traders, they are in the urban area. That's what you're looking for. So wherever you see Muslim is going to be 1. Wherever you see traders is going to be 1. Wherever you see urban is going to be 1. Everything else is going to be 0. So we come down here. The first one we had urban. Oh, good. That's 1. Because these people are truly in an urban area. Then we are told that we are told about occupation teaching. But from the story, the people are not teachers, they are traders. So occupation teaching will be 0. Then we have occupation trading. Oh yeah, because we're told that the people are traders. So occupation trading will be 1. Then we have religion Christians. What will be the value there?
0.
Because the people are what?
Buddhists.
No, they are not Buddhists.
Muslims.
They are Muslims. See, people are not paying attention. Because they are Muslims. Okay, because they are Muslims, this religion Christians will be 0. But this religion Muslim will be 1.
1.
This is 13 marks. This is your highest mark. If you lose this, you lost everything. That's why it's important. You follow the drill. So once you have filled it, so this is a filling. I've done the filling here. The first one is 15, then 15, then 20, then 1, because that was the urban, then 0 for the teaching, then 1 for the trading, 0 for the Christians, and 1 for the Muslims. You combine all of these together and you get a certain value. What value will you get?
Thank you so much.
What value will you get? But the class reps and those who have been made co-hosts, you are supposed to mute anybody whose microphone is on. Yes, Grace.
Please, that will be 136.79.
Perfect. That is another 3 marks for you. Okay. You got to follow and pay attention. Immerse yourself in what we are doing. There is no way you won't get an A in this module, but it has to be guaranteed because you have participated fully today. Okay. So 136, 137, there will always be a difference, and the examiner will always give a difference, an approximation value. So you will normally have something like 138, between 135 and 138. Okay. And that's how you get a thing, between 135 and 130. So anybody within that range, the person did the calculation well. And that is the answer. And that is the, so this is the quantity demanded for the first scenario. Now, in the second scenario, look at it. We are told that the people are Buddhist fishers in a rural area. Watch it. Keep that in mind. Buddhist fishers in a rural area. Nothing else changes. What will be the value of P? In that second scenario, what will be the value of P? It will still be 15. It hasn't changed. What will be the value of C?
15.
15. It hasn't changed. M?
20.
Good. Now come back to the realities. The location urban, what will be the value? The people are Buddhist fishers in that area. What will be the value of urban?
0.
Occupation teaching.
0.
Occupation trading.
0.
Religion Christian.
0.
Religion Muslim.
0.
So that is it. They will all be 0 according to the principles. And when you do that, you're going to get 211.62 approximately. So we now compare the two scenarios. Which one do you think has more quantity demanded? First scenario or second scenario? Which one? Jonathan?
First scenario.
First scenario. That's wrong.
The second scenario.
The second scenario has got more quantity demanded than the first. By how much? It's got more quantity demanded by how much? Felix.
By 74.81.
Exactly. Okay. By 74, approximately thereabout. So in the problem here, you can see that we have 137 and 211, which is more, 74 higher than the first scenario. It's showing that the second scenario is the better option. Now, what do you think is driving the differences? What do you think is driving the differences? Felix, what is driving the differences? Samuel.
I think it's the religion.
Is it only that? Is it only religion? Jonathan.
The religion, the location, and occupation.
Exactly. 2 marks for you, Jonathan.
Thank you. Thank you, sir.
The location and that of the occupation, because these are the factors that were changing between the two. Okay. Those were the factors that were changing, and that is what it is. Master prediction. Mature it. Don't keep it in your head, keep it in your kneecap. Wisdom is the ability to see the obvious, even when it is a secret. The last thing we're going to look at today is multicollinearity. Multicollinearity. Okay, and that is the third thing.
There is no data.
Multicollinearity happens when two independent factors are so highly correlated that it's so difficult to even disentangle the partial effect of one from the other on the dependent variable. The definition is there. But there's one critical thing about multicollinear variables, and it is the fact that it has to do with independent variables. You see, when you do your correlation matrix, and I'll tell you about the correlation matrix very soon. Okay? When you do your correlation matrix will show clearly that some of the independent variables have got high coefficient. Now, let me tell you something about independent variables. Independent variables are variables that are independent. Independent. Which means they don't depend on anybody. They don't depend on anyone. They are exogenous. And so if it happens that that variable is found to be highly dependent or highly correlated with another one in the same environment, that is not good. When you have an independent variable like price, so highly correlated with another independent variable, say complement price, that brings an issue because their partial effect on the dependent variable cannot be easily detected. It's difficult to disentangle them. A typical perfect multicollinear variable is male and female. When you have male, then 1 minus the female is male. There's sometimes height and weight are multicollinear. Your height is related to your weight. If you check, as you are growing taller, you're also expanding. Sometimes experience and education are highly correlated, but they are not perfectly like, perfect complement. Sometimes we say that the multicollinearity can be a curse. And it can make all the regression predictors redundant. Now, if you have a lot of multicollinearity in your model, you will still have R squared to be big. Your R squared is going to be big. Your beta parameters are going to be unbiased. They are called blue, best linear unbiased estimators. They are blue, which means they have minimum variance. The variances are things that you don't. When you have a minimum variance, that is good. But when you have large variances, that's bad. When you have large errors, standard errors, that's also bad. And when you have such a problem, you can commit type 1 error. So what do? First, check the variance inflation. Check the variables. Check whether any of them is exhibiting multico. Check whether any of these independent variables are exhibiting multicollinearity. How do you check it? You use something called scatter plot. That's number 1. 2, you use something called variance inflation factor. 3, you use something called tolerance level. You get questions on all this, so take note. But the major one we are going to look at is the variance inflation factor. What does it do? Well, the word says it by itself. We don't want an inflation in the variances. You see, I told you that when the variances are inflated, that's not good. So we calculate the variance inflation factor for each independent variable. R can do that. When you go to your R, you can use that to calculate. The key point is after you've calculated the variance inflation factor, if it is equal to 1, then it means that the two variables have no correlation with each other. No wahala. But if it is bigger than 5, moderate multicollinearity. If it's bigger than 10, serious, severe multicollinearity. You should know that. In the case of a simple regression, the variance inflation factor is equal to a certain number. So think about that. So I want you to look at this thing. We already seen this multiple times, this result multiple times. We can generate the variance inflation factor, okay, of the relevant variables. And you're going to do this also in your assignment. And then you identify 2 pairs of most multicollinear regressors that may be deleted. You see, the final thing, if the variables are highly multicollinear, is to delete them. Well, delete the one with the highest or higher variance inflation factor. But the deleting is the last resort. Don't delete, investigate. But deleting is the last resort. So we're going to generate the variance inflation factor for each independent variable. You will invoke this library, if you are doing it in R, invoke this package, okay, and then you can calculate the variance inflation factor for every individual using these blue codes. If you do that, you're going to get this result. I have a question here. So let's first look at price. The variance inflation factor for price, is it good or bad? Let me look at this. Is it good or is bad for price? All of them are not good, relatively speaking. But if we are to take some of them, which one is probably the worst? Remember, you don't consider the variance inflation factor for the dummy variable or the categorical variables, location, occupation, and religion. And I've asked this question in your question, why you don't consider them is important. Okay. But if you take those ones out, price is a problem because the variance inflation factor is 24. Complement price, well, income, well, but then the key problem is price. Price is a big deal. Price is a main determinant of quantity demanded. So to actually also drop price is a big issue. That is why you never drop it until the last resort. You can handle variance inflation factor, multicollinearity. You can handle multicollinearity, okay, by following some of these methods that have been discussed here. But I've asked the question again, why is it not a good practice to consider the variance inflation factor for dummy variables? I've asked that question multiple times. Check it. Check why. Check why. Check why. Now, when you run the regression using these library tools called J2s, you will get the entire regression, the same thing I had before, but this time at the far right, you will get the variance inflation factor on the far right. So this is the variance inflation factor for each variable. I'll give you the variance inflation factor. I have also given the variance inflation factor for the dummy variables, but like I said, don't use that. Don't you discuss the variance inflation factor for dummy variable. I've said it many times. But more importantly, go and find out why you shouldn't do that. So how can you solve it in case that you feel that there's so much problem of multi-co in your data set? But there are 4 ways. Remove one or of the variables, one at a time, and rerun the regression. So let's say you remove price, you rerun the regression, you check whether everything is going to be good. Okay. And then you put it back. You remove the next one, income, and then you run it. You put it back. You remove, complement price. You run it like that, one at a time. Okay. Those that are reducing the R square and those that are making the other variables insignificant are the ones you watch out. 2, you can linearly combine some variables if it is possible. Okay, you can subtract some variables from the other. You can multiply some variables with the other. You can add some variables to the other so that we don't have any wahala. 3, you can perform principal component analysis or partial least squares. And you can even go to do something we call ridge regression, lasso regression, elastic net regression. These are machine learning models. Again, this is for your future research you are doing, for your thesis you'll be writing next year or next academic year, but it's very practical for you to note all this. So, ladies and gentlemen, that brings us to the end of the entire caboodle. Okay, we've come to the end of the regression result. Next week, I'm going to tell you the exam areas, and we are also going to look at some questions for you to prepare yourself out. At this stage, if you have a question, please let me know.